All right. Very good morning. Very good evening, everyone. Right. Let's get started. Quickly, just to recap what we covered yesterday. I'll spend few minutes and then on the recap, and then we can continue further discussion on those technical concepts. Now we started with the introduction about your instructor. That's about me. I'm your instructor. I'll be taking this RAC course end to end. So we briefed about my overall experience, my areas of expertise, and my major accomplishment, and you know, other than Oracle, what are the other technologies what I incorporated, and then what are the major project what I handled in my IT career. So that's a overall about your instructor what we seen yesterday, and then we briefed about the course curriculum. And here's a course curriculum link. Again, hope you have gone through this course curriculum link. If not, I'm pinging this link here in the chat. You can take a note of that. Go over on the course curriculum. So I can quickly show it one more time here. Right. So this is the course curriculum. We briefed and each and every topic what we're going to explain in this course. Right. And then I request you to go over this one more time and see if any topic is missing from this list. That what you are looking for, right? And then we discussed about the upcoming batches and the current course timing, current course date and time, and the fee structure. So this batch is weekday batch, Monday to Friday. In those weekdays, we'll be conducting 2 days classes, Thursday, Friday, 2 days in a week, 3 hours each day. So 8:30 a.m. IST to 11:30 a.m. IST, 3 hours on Thursday and 3 hours on Friday. In Eastern time zone, it will be Wednesday and Thursday. It will be late night, 11 p.m. to 2 a.m. EST, 3 hours. Maybe in 7 weeks, we should be able to complete this course. And again, this is a paid training. 15K is a course fees or 185 US dollar. And it will be conducted on via Zoom session. And it will be covering 19C database version or 19C Oracle version. So starting from the next week, next Thursday, that is 17th July 2024, 2025, where the actual class, maybe that is next coming Thursday, we'll be starting this course. Right, that's about the course duration, timing, fee structure, and two important aspect what we talked about yesterday about Google Drive. Upon the registration, you will get access on the Google Drive and will be added to WhatsApp group. WhatsApp group is for all the communication, all the discussions, questions, queries, and any help assistance. We'll discuss everything in the WhatsApp group. Google Drive is all the course materials, course PPTs, lab exercise, workbook, and the software, all the interview questions, answers, and automation script. All the previous batch recording, current batch recording, all will be uploaded into this Google Drive. And then we got a few more registration yesterday after the demo sessions. Again, whomever interested, feel free to reach out to me on this WhatsApp number or call me on my cell number. I'll leave further process or further guide you to payment processing. There are many ways to do or perform the payment mode. You can choose whatever comfortable on that. That I pinged here my WhatsApp number, cell number on the chart. You can take a note. And then we talked about the prerequisites. Very, very important. You should understand what are the prerequisites are needed. And upon meeting all the prerequisites, you can go ahead and then register for this course. And post yesterday's discussion, I got a couple of one-to-one personal pings saying that I don't have enough resource on my laptop or desktop. I have only 8 GB, I have only 12 GB, but still I want to continue the course. So again, if you don't have this hardware requirement, you'll not be able to set up a lab. So if you're okay that I can watch your recording, whatever the demo I'll be showing it, I'll see that recording, and whenever I get my new laptop or whenever I get the enough resource on my laptop and hardware, I can practice it. For now, I would like to continue the course. That is all you are taking a risk. Risk meaning without hands-on, I don't prefer to anyone to continue the course, because once you do your hands-on, then only you will understand, you will get a confidence level. But post that you still want to continue, you can go for this course without lab, but you should be able to concentrate on what I'm teaching and what I'm showing a demo. You have to depend on that. So you don't have any way to do your hands-on exercise until you set up a lab on your laptop with this requirement. Right, that's a must thing. Remember that one. But still, you want to continue? Yeah, you can go for that. Right, basics of Linux, Windows, database knowledge, pre-database knowledge are must, and this hardware requirement is must. However, like a few couple of things I got. What is the best recommendation for the laptop? You can go for HP laptop or Dell laptop or Innova, whatever. But make sure that you have this minimum 32 GB RAM, minimum 250 to 500 GB SSD, minimum 2 to 4 CPU, and go for any processor with i9, i11, or whatever the latest processor. So with this configuration, you can able to easily complete your database course, RAC course, and DR setup, OEM setup. All will be possible with this configuration. Right, and then who all can attend this course? Any DBA with 1 year experience, 5 years experience, 10 years, 15 years of experience, anyone can attend this course. But prior DBA knowledge is must. Right, and then we talked about certificate, DBA certificate and the RAC certificate, very, very must to minimum certificate. You have to do it. So with this certificate, that when I add you advantages in your resume. So your resume becomes stronger with this certificate, so that whenever you apply for the job opportunities, your resume will be stronger and it will get shortlisted upon completion of this certificate. You're going to put that certificate logos in your resume. Right, and then we talked about some current technologies, cloud, AI, DevOps, and which cloud technologies are good. And we talked about if there is any career experience, career gap, or professional experience gap, how you can deal with that. Can I use a fixed experience or can I get some recommendations? So those are like challenging questions or the career aspects what we discussed. And then post that we started with some technical discussion where we started with the understanding of standalone versus rack and type of databases. And type of databases are standalone and rack. In standalone, again, standalone with ASM, standalone without ASM. In rack database and rack per node database, what we understood. And then standalone versus rack. So three major feature or advantages what we understood about high availability, load balancing, and failover. So those are the two concepts what we talked, and then we can continue further in these technical concepts here. Right. With that, I'm gonna take a pause for a minute, if at all, if anyone has any further questions based on our yesterday discussion. If no question, I can continue further on the some more topic discussion today. Right? Any last minute questions? No?
Yeah, so
Yeah,
hi, good evening. So I was just saying, good morning, sorry, good morning. So I was saying that my computer also doesn't have much resources.
Right.
So I might have to buy a new computer very soon. I'll buy, but until then, can I continue just listening and
Right.
etc.
I can do that. As long as you're trying to arrange a laptop and you can get it in next 1 week, 2 week, 3 weeks, you can continue, no issues. You can practice it
Okay.
little later.
And
All
I'll
right.
send the
yeah.
payment. I'll send the
Actually,
payment.
getting the
I'll send the payment directly to your bank. Huh?
Yeah, you can ping me. I can guide you through that.
Okay. All right. Thank you.
Right.
yeah, I pinged you yesterday regarding addition of the new WhatsApp group.
I'll
I
do
don't
that.
know whether I have added or not.
Not yet, not yet.
Okay.
I'll take care of that. All right.
I have a same thing actually. I don't have enough resource in my laptop, but I have the same environment, RAC environment in my office. So I have that non-prod servers there. I can just do the testing.
Yeah, so you can do some selective practice over there. You cannot practice the destructive operations like shut down, stop, start, and drop. All those kind of activities you cannot perform, but you can do a hands-on look and then select queries and all those things.
Yes, yes.
All right. So with that, quickly, so we understood about these questions yesterday. Why rack? What are the advantages of rack? So high availability and load balancing and failover are the three fundamental advantages and the need why rack is so powerful than the standalone. So we talked about HA, high availability. If one node is not available, the incoming request will be served by the other nodes. So what are the, like in simple definition, if I give few points on that, multiple rack cluster nodes. We call it as the nodes in rack. One node, two node, three node. It's basically server, host one, host two, host three. Those are your Linux server. We call it as a cluster nodes. So multiple cluster nodes will help in end user connection. In case of any node is down, we have a other node will help us establishing the connection. So here scan will come into picture to serve that incoming connection, because from the end user point of view, he don't need to remember that node 1, node 2, node 3, node 4, node 1 IP address, node 2 IP address, node 3 IP address, node 4 IP address, nothing like that. It's just one single scan name. The scan is aware of what all the cluster nodes. Is it a 2 node cluster? Is it a 4 node cluster? Is it a 8 node cluster? And then scan is aware of if the node 1 is down, scan will mark internally node 1 as a down, and then scan will only activate those remaining nodes, node 2, 3, 4, and any incoming request directly go to either node 2, 3, 4, and it never send it to node 1 which is down. That's the beauty of scan is all aware of what all my cluster nodes, out of that which all nodes are active and which all nodes are down. And scan will serve as a client side connection high availability and server side connection high availability, or server side connection load balancing. So again, this is all too internal to scan. We probably explore more what exactly mean by client side connection high availability, server side connection load balancing. So we'll actually see in our regular classes. So with all these features, we should be able to achieve this high availability. That's one of the main feature of your rack. Coming to load balancing, the other major feature, I can make it as a point number one and point number two. And in this load balancing, who is responsible for load balancing? So we discussed again yesterday, scan is responsible for the load balancing. And then what exactly is the scan? Scan is a single client access name where end user can easily connect to my database using the scan. And then this scan is made up of a default scan is made up of three IPs, or in fact three VIPs. So with help of these three scan IPs, we can able to achieve the high availability, the client side connection high availability, and also with the help of three scan IPs, if one of the IP is not working, you have another two IPs to serve end user connection. So why only three IPs? Why can't we go with the one IP, two IP, four IP, five IP, six IP? Yes, you can go with whatever number of IPs you want it, but it has its own IPs. Why the default is three? Default is three. Three is more than enough to serve all the client connection and support your high availability and load balancing irrespective of whatever your cluster size is. Is it a 2 node rack cluster, 4 node rack cluster, 5 node rack cluster? A 3 is more than enough. And I have seen even a scan with a 5 node and scan with a 7 node or 9 node scan IPs. But again, we'll explore more in our regular classes how you can configure the scan and how you can set up this multiple IPs inside the scan. The scan is able to perform load balancing. Yes, that's the main job of the scan. So these are your interview question. How scan is able to perform this load balancing? How my scan is aware of my rack cluster node 1 is connected with the 10 user. My rack cluster node is connected with the 20 users. And then any new user comes, the connection will go to my node 1 because node 1 has a very less load. Only 10 users are connected. Node 2, 20 users are connected. That's a more load over there. How my scan is able to interpret the load on each of my cluster nodes. Based upon that, it will route the connection. And then how scan is able to identify the load of a server, how many users are connected, how many transactions are going on that particular node. And then how many IP scan has. So I just mentioned default is 3. If you don't specify it, Oracle will standard tells us to do a 3 IPs for the scan. Again, it is not a fixed rule or thumb rule. You can go with the 1 IP for the scan, 2 IP, 4 IP, 5, 6, 7. It is all left to you. But again, why those multiple IPs? That is for client side connection high availability. If one of the IP is not there, the second IP will pick up that client connection and proceed further with the establishing the connection to my database. And again, is the scan is a VIP or the physical IP? A scan is a VIP. So again, what is VIP? That's a separate topic. We'll talk on that. And can we call it as a scan IP or the scan VIP? So some people will call it as a scan IP or some people will call it as a scan VIP. Both are referring to one and same. Right. So those all many more to cover on that, but these are the a few words or few general terminologies what we regularly use. Right. And coming to failover, what we discussed yesterday, if the client is connected to node 1, if the node 1 goes down, automatically his connection is going to connect it to second node or the third node or the fourth node in my rack cluster. Is my failover supports DML query, DDL query, TCL query, select query? What kind of a failover it is? We have two types of failover: select failover or session failover. If the user is connected, his session should fail over. If user is connected and is doing some select query and fail over that select query, wherever it was, fail over from that point and then continue from where it has left out. If it's a session query, if that user is doing some transaction, cancel that transaction. Once the failure happens, again restart it from the scratch. So what kind of a failure you want, select or session? You have to configure, you have to choose that one while configuring. How we are able to, or how the rack is able to provide failover feature. How we are able to achieve this one? VIPs will help in achieving this. So this failover will be achieved with help of VIPs. So again, one of the entry questions, why we need VIPs in rack cluster setup? So with the help of VIPs, we are able to achieve this failover. Again, how we are able to achieve, we'll take a look in our regular classes. And then again, for further question two on this one, what all the transactions are supported failover? So only select queries. Only select queries are supported for the failover. If the user is doing some DML, like insert, update, delete, those failovers are not supported. The sessions will be failed over and the user has to resubmit that a transaction again if it's an insert or update or delete. All right. So that is a further in-depth understanding of what we discussed: high availability, load balancing, and failover. So let's talk about some networking now. So far so good. Any questions here? Again, these are like, you might not be getting some of the concept here, what I just explained, but these are your expected keywords or terminologies or expected interview questions. It's not just like what is failover, why we need a VIP, and who is responsible for failure, how this failure exactly works, what type of a failures are supported, and what is scan, how many IPs are made up of scan, is a scan VIP or the virtual IP or the IP or a public IP or a private IP, and why we need default three IPs. Can I go with one IP, two IP, three IP, or five IP, eight IP? Then how many scans are needed for rack cluster? And what is the client side high availability, server side load balancing, how my scan is aware of how many users are connected, and what's the load on my cluster nodes, how my scan is aware of that. So those are like internal to all these features. Again, that will be discussed in more details in our regular classes, but take a look on these particular keywords, and you might have heard these keywords repeatedly if you're already working on a rack, and your seniors, or maybe in most of the interview you might have heard these kind of a keywords or questions. But yeah, that is a fundamental of a rack. You should be aware and you should be able to answer all these questions without any issue. Because once you understand the rack architecture and foundation, all are depend upon these fundamental concepts. All right. Let's say when it comes to network, very first question, how many IPs are needed for setting up two node rack? One of the basics default question, how many IPs are needed? And what are the types of IPs are needed? Right, so in a simple definition, I'll go with the two node rack setup, node 1, node 2. So for node 1 and node 2, very first thing I need is a physical IP or public IP. We call it as a physical IP or a public IP. That's a very first IP what I need for both the nodes. So what I'm doing here, I'm setting up of node 1, node 2, two node rack setup. And these two server together will form my rack setup. So inside that will be running ASM1, ASM2, and then my database instance will be running database instance 1, database instance 2. All of them, both of the database instances will be having your database here. That is on ASM storage, ASM disk group. So very first IP what we need, a public IP. That's the first IP what we needed here. Two IPs for node 1 localdomain.com, node 2 localdomain.com. And the second setup IP what we need, a private IP. We'll give node 1 preview localdomain.com, node 2 preview localdomain.com. I'm just giving this some random IPs here. 192, 168. Give me a second. All right. Sorry for that, guys. We need two set of private IPs, node 1 prive and node 2 prive localdomain.com. Again, if you quickly take a look, public IP will have this 1.101, 1.102. So this is a different subnet, different IP range, and the private IP 2 dot. It is 1 dot series and it is 2 dot series. 2.101, 2.102. So your private IP should be in a different subnet. And then another setup IP what we need, node 1 VIP, that's a virtual IP, node 1 VIP, localdomain.com, node 2 VIP, that's a localdomain.com. So again, this is in same range of that public IP. So very first set of IPs, two IPs are public IPs, which is this 1 dot series. And again, another set of VIPs, that is same range, 1 dot series. And these are your must IPs, two public IPs, two private IPs, and two VIPs. And on top of that, the scan IP, scan VIP or the scan IP, scan.localdomain.com, default 3 IPs. So again, that also will be in the same 1 dot range. So in order to set up a 2 node rack, we need 2 plus 2 plus 2 and plus 3. So those are your minimum needed 9 IPs. So again, some of them are VIPs and some of them are physical IPs. So you need total 9 IPs to do a 2 node rack setup. If you want to add one more node, you need 3 more IPs for that. Node 3, public IP, private IP, and VIP. Add up those 3 more IPs. They'll become 12 IPs for 3 node setup. And you need to add one more node, fourth node. Again, you need another 3 more IPs. Public IPs, private IPs, and VIPs. And that'll add up to another 3 more IPs. So that will be again continuous based upon how many node you want to configure in rack. Right. So here we talked about multiple IPs. We talked about a physical IP. Physical IP is nothing but a public IP. We talked about public IP. Why public IP? Why we need public IP? We talked about VIP here, these two VIP. Why we need VIP for rack setup? And we talked about scan IPs. Why we need this scan IP? Why Oracle has come up with these many IPs? Do I just have this physical IP and then install my rack setup? Why we need so many IPs? So there's a fundamental history for that, why Oracle has come up with these many IPs. So prior to 10G, we had only the physical IP. There is no VIP concept. There is no scan concept. We had only this node 1, a public IP, node 1. So you can put again, sometimes or sometimes people will call it as the public IP or the physical IP. Both are one and same. So prior to 10G, what used to happen? Right here. Only the public IP, no VIP and no scan IP. So what was the limitation if that's the case? And the challenges here was in 10G, prior to 10G, 9i, there is challenges like no failover, and failover was a challenge, and so this was one of the challenging concept in 9i or prior to, and the same thing for your load balancing. Load balancing also a challenging. And the client used to connect using the node IPs or the node VIPs. And whenever you adding a node or deleting a node, again that's also challenge. Every time client has to reconfigure their configuration. So these all are challenges in the 10G, prior to 10G. Like whenever client is connected, the connection randomly used to go to node 1 or node 2. There's no proper way of assess how many connections are node 1, how many connections are node 1, what are the activities node 1 is performing, what are the activities node 2 is performing. And then connection is to either go to node 1 or node 2. Always node 1 will be overloaded or node 2 will be overloaded. The load is not properly distributed, or the connections randomly used to go to any node, and then we'll not be able to do a load balancing. And right now it is a two node, and whenever you add a third node, the end user has to reconfigure all their settings, and the application team has to reconfigure all their settings and include that third node details. Because we used to configure using the node IPs, only the physical IPs. The moment third node is added, you need to add the third node physical IP details into application or the end user connection TNS details. These all are the challenges prior to 10G in 9i and other version. So in 10G, what happens? We came up with, Oracle has came up with a VIP concept. In 10G, Oracle has introduced this VIP concept. Along with this, now public IP, we got now VIP. So we got two set of IPs in 10G onwards. In 10G rack setup, we have this a public IP and the VIP, two set of IPs Oracle has came up with. So with help of this VIPs, what happens? We were able to achieve a load balancing. Earlier, these were the challenges. With help of this VIP concept, we achieved this one. Meaning, if suppose any user connected to node 1, they will connect via this VIP. And the moment node 1 goes down, your physical IP, whatever the physical IP is assigned for this node 1, the physical IP and VIP and then private IP. Again here also physical IP, VIP and then private IP. The moment node 1 goes down, your physical IP will go down, but VIP will not go down. Your VIP will fail over. The moment your VIP fail over to second node, all the connected users from node 1 to node 2, they fail over. So we are able to achieve the failover by introduction of VIP in 10G. So because of that, Oracle end up with a physical IP at node level, VIP to support that failover. But load balancing is again challenges. So in 10G, we don't have a proper concept how many users are connected on node 1, how many users are connected on, give me a second. So how many users are connected on node 1, how many users are connected on node 2, and then what is the transactions are happening on node 1, what's the transaction happening on node 2. Those kind of a load balancing to assessing those rack cluster node was not there. And right now it is a two node. And whenever you add a third node, again your application team or the end user has to reconfigure their TNS application settings to include that third node physical IP and VIP. These two are remain still challenge in 10G. And then in 11G, Oracle has introduced this scan IP or the scan AIP is introduced in 10G. So now we end up with a physical IP or call it as a public IP, and we have now VIPs which is introduced in 10G, and then now we have these VIPs on the scan IPs. Three set of IPs we end up with in 11G onwards. And with help of this one, what we are able to achieve? Failover is already achieved in 10G. Load balancing we achieved with help of this scan. With help of this scan I just mentioned in yesterday and also today, scan is intelligent enough, smart enough, is aware of how many users are connected on node 1, how many users are connected on node 2, and what kind of a transaction they're doing on node 1, what kind of a transaction they're doing on node 2. My scan is smart enough to assess that all the cluster nodes and understand what is the load. So we're able to achieve this load. Once your scan is able to achieve the load, scan can take the incoming client connection and route the connection to suitable cluster node, which is having a lesser load. And we're able to achieve with the help of the scan. And also node addition and node deletion. Right now we have two nodes and you're going to add the third node. You no need to reconfigure your application. You no need to end user, no need to reconfigure the TNS entry because they're using a scan name, one single scan name. My scan is smart enough to understand how many cluster nodes. Right now my scan can understand this cluster is made up of two nodes or the two IPs or two physical IPs, two private IPs or two VIPs. Whenever you add a third node, my scan is able to understand this cluster is made up of third node. For the end user point of view, he has to remember only the scan name. He no need to remember this all the three node host name, IP address, VIPs and public IPs, private IPs. He no need to remember. My scan is able to serve that all the backend settings. Node addition and node deletion we are able to achieve with help of scan because scan is able to understand what are the active nodes, how many nodes are configured in this RAC cluster, how many of them are down, how many of them are still alive, and if any one new node is get added, or if any of the cluster node is got removed. So all of them scan dynamically, understand and update internally. And for the end point of view, end user no need to remember all those new node, new IPs. He just need to remember that one scan name. Right. So because of this, over a period of time, Oracle is evolved and Oracle has done many IPs and we end up with this IPs for any rack setup. Public IP, private IP, VIP and scan IP. Hope that is clear. Any questions so far? I'll take a pause for a minute on understanding of these IPs. Any questions so far? So good.
Sir, this is Manohar.
Yep.
For two node configuration, is that scan is should be only three, or it can be reduced?
I
It can be
mentioned
reduced.
that one, right? Scan, there's no hard rule or thumb rule. You can configure it 1, 2, 3, 4, 5, 6, 7, 8, but default is 3. So again, why multiple IPs? To support this a client side high availability. The scan has to perform client side connection high availability. If one of the IP is not available in scan, other scan IP will take that incoming connection and then serve that end user connection. So if you go with only one scan IP, let's say that scan IP is having some issue at network, none of the end users is able to connect to your database
Yeah,
because that IP has some issues.
yeah, got it. Thank you.
That it means three IPs is the minimum requirement for the scan site. Scan VIP.
No, go with one also. Go with the two also. Works
Okay.
fine. You can go
If
with the
we
5,
have a
10.
two node, yeah, then we have a two node rack. Then it's required the uh, three
Yeah,
VIP,
3 is the
right? Scan
default.
node.
Yeah, 3 is the default.
Okay,
Even
three.
if it is a 3 node rack, 4 node rack, 5 node rack, 8
Mm-hmm.
node rack, 10 node rack, 3 is minimum. So 3 is a good practice.
Okay, doesn't matter of the node of the rack, right?
Right. That's correct.
Yeah. Thank you.
All right. Again, this is not enough. Like I just given you overview or brief. If you go in depth and actually once you connect your rack cluster and then map those all those public IPs, private IPs, scan IPs, and then you'll understand more. But for now, it's more than enough to just to remember these keywords. And again, this is your one of the inter questions. Why three IPs or why multiple IPs are needed for scan? I just explained about to serve this a client side connection high availability. One of the scan IP is busy, then it will other scan IP will activate and take that connection and then route connection to any of the cluster node. Again, these are the questions. What is physical IP? The IP assigned to interface. ETH0, ETH1, ENSP0, ENSP1, whatever the interface, bond 0, bond 1 in your server, those are your physical IPs. Or you call it as the public IPs. So physical IPs or public IPs are nothing but the IP assigned to an interface in your Linux server. What is VIP? These VIP do not have any interface. Like whatever the interface you see here, those interface, they will not be assigned it. They will be assigned it to that virtual tagging, we can call it as. You have this ETH0 and then your VIP will be assigned to ETH0 colon 1, ETH colon 1 or colon 2. So it may be colon 1 or colon 2, colon 3, colon 4 based upon how many VIPs are assigned on that server. It will be like this colon format because they don't have an actual physical interface. Physical interface is available only for these physical IPs or public IPs. What is scan VIPs? Again, scan VIPs are nothing but the whatever the VIPs. Again, these IPs do not have any interface. It's same as what we just talked here. And again, they will be tagged to that colon 1, colon 2, colon 3, kind of whatever the available interface, they will be tagged over there. And private IP is nothing but, again, it's kind of a physical IP. Whatever this physical IP what we saw, your private IP also a physical IP, but it's in private network. And this physical IP is in public network. That's why we call it as a public IP or the physical IP. Your private IP, that is also a physical IP, which is in a private network. Is nothing but a physical IP, but in a different subnet than your a private IP or the physical IP here. So then that is also will be tagged to a physical interface. The moment you say physical interface, the whatever the interface you see in your Linux environment, ETH1, ETH2, ETH3, the IP is assigned to that one. If any IP assigned to that one, those are called your physical IPs. It may be in public network or it may be in private network. Based upon that, you can call it as a public IP or private IP. Right. So here, this is public IP and your private IP also a public IP. Sorry, a physical IP. You call it as a private IP or a public IP, or both of them are belong to a same. Right. What I mean is here. Right. You both public IP and private IP are the physical IPs. And why we call it as a public IP? Because that IP is in a public network. And your private IP is also a physical IP, but that is in a private network. This is the 2 dot subnet and this is 1 dot subnet. And both are physical IP. What is physical IP? The IP is assigned to an interface, ETH0, ETH1, ETH2, ETH3. If you see the IP assigned for that interface, those are called your physical IPs. And based upon which network they are in, public or private, we call it as a public IP or private IP. Right. Again, these are your expected interview questions. What is public IP, private IP, physical IP, scan IP, and VIPs? Right. Again, other question. I just covered it, but one more time. Is a scan VIP or a physical IP? A scan is a VIP. And other few more questions. Why private IP is in different network? So we talked about here a private IP is in different network 2 dot and public IP is in 1 dot. So that is one common question again. Why it should be in different network? Why can't it be same as? Why can't in the same network of physical IP or public IP? Why can't you have this private IP in the same that 1 dot series? Because your public IP, your VIP and scan IP, all of them are the same network here, 1 dot series. But why this private IP into a separate network? Right, that is maybe again one of your common entry questions. So there are many reasons for that one. A private IP is more used in my cluster, heavily used in my cluster, the private IP. Because of that, it is advisable to run in a different network so that it will not interfere with your client connection, client network. So for the network heartbeat or disk heart check, or you can say heartbeat. So again, what is network heartbeat? What is disk heartbeat? Node to node communication is called a network heartbeat. Node to voting disk is called your disk heartbeat. So again, what is voting disk? Again, that is internal to your rack. We'll discuss more in our regular classes. And to have this cache fusion, what is cache fusion? Transferring the data blocks between one instance, the database instance 1 to database instance 2, or database instance 2 to database instance 1. The data blocks are transferred between this buffer cache to buffer cache between the two database instances. That's called cache fusion. And the entire cluster communication for all these activities, you need that private IP. Because of that, it is very, very advisable to run your private IP in a different network, and only your rack cluster setup works if you provide a different network. If you provide the same network, your cluster installation will stop there only. It has to be in a different network because of all these conditions. And then the other point what we discussed, my physical IP, that's a public IP, VIP and scan IP are meant for the client connection. So my end user connection works on the scan because the scan name, we're going to use it for the end connection. Via scan, the connection will go to my VIP, and via VIP, connection will go to my database. So for the client connection, for the client transaction, we are going to involve this scan IPs and scan VIPs. So because of that, that should be in a separate network. So based upon your scan VIPs and your node VIPs, your physical IP or public IP also will be in the same range. Right, so those are again network high level overview, but once you start installation of your rack cluster, you'll understand more on that. Right. Now let's go for a little bit on the same concept here. The node 1, node 2, all these IPs what we assigned. And in prior to 10G, how the installation used to go. We have two separate software. Before 10G, Oracle has two separate software. Let's say, give me a second here. Okay. Clusterware, software, and then ASM software. So what we used to do prior to 10G, Oracle used to give two softwares, a clusterware software and ASM software. So in order to set up this two node rack, we used to install cluster software, download this cluster software and install it. Let's say something like this. Right, we used to install U01 cluster, download this clusterware software and install it on this location. And then second step, what you used to do, install ASM software, download this ASM software and install it, U01 ASM. And then third step, install DB software, U01 DBM1. I'm just giving a rough naming convention here, just to ease of understanding, but actual paths will be in different. So there used to be three software installation: cluster software, ASM software, and database software. And then with help of this cluster software, which will help in node 1 and node 2 communication and make 2-node cluster. So this cluster software used to establish this node to node communication and form your cluster after installing this software. After installing this ASM, we used to get ASM storage. Why ASM storage? Because we are going to keep our database on ASM storage. After installing this ASM software, my ASM storage my ASM disk group used to get created. After installing this Oracle Home, we can create any database. So there are three softwares. Each of them will act its own purpose. So post 10G, after 10G, what Oracle has done? Why should we go with this mess up, like installing multiple softwares and make it DBA life hectic, right? So what Oracle has done? They combined this cluster software and this ASM software together. They call it as a grid. So now we have only grid software and then database software. Now you define all these IPs. After defining all these IPs, now we no need to download these three software. We just need to download only two software. A grid software, which is a combination of your cluster software plus ASM software. Right? Cluster software and ASM software together, Oracle came up with this new software called grid. And we'll do the same thing. On both node 1 and node 2, we'll just install a grid software. Install grid software. That's download your grid software from Oracle support and install it, like use your own grid. The moment you install this grid, we're gonna help in communicating between node 1 and node 2 and then make 2-node cluster. And at the same time, we used to get ASM storage and ASM instance. Both of these activities are performed with one single software now. Rather than it has combined both the tasks together in one software. And then second software will go out and then install our database software. My Oracle Home is ready here. And then you can go and then create our database with the help of this one single software. Right, so that's why the changes happened in 10G onwards. So there's only grid software and database software. With the help of this one, many people will call it as a grid software or clusterware software or ASM software. One and same. All are one and same. Some people will call it a grid software, clusterware software, or ASM software. Just remember, those all are one and same. After installing this software in this location, use your own grid, people will call it as a GI home or ASM home or clusterware home. Again, one and same. Many people will call it as a different keyword, but here all are referring to same. Right, and for the database, we call it as some people will randomly call it as a Oracle software or database software or DB software. Right, so these are like referring to Oracle software. Again, those are like one and same. After you install this Oracle Home, people will call it as a Oracle Home or DB Home or Database Home Again, these are again one and same. So with help of Oracle software, database software, or DB software, we install Oracle Home or DB Home or Database Home. These are like one and same. With help of this grid software, clusterware software, or ASM software, we install that grid home, ASM home, or clusterware home. Again, these are one and same. Right, so those are your fundamental, the installation process, how it works, and the network, the requirement, how it works in case of if you want to set up this two node rack. So again, I'm giving just example with reference to this two node rack cluster. But if you start working on the client, you can see 3 node, 4 node, 5 node, but fundamental understanding remains same, what I'm explaining today. Right. So now, little bit again, if I go further, the installation, the GI grid infrastructure software, the ASM software, clusterware software, the GI home, ASM home, clusterware home. So again, all are referring to same. We will install it. And again, for the Oracle one, the Oracle software, database software, Oracle home, database home, and even some people will call it as a RAC home and RAC Oracle home. All are referring to the same thing, what I just mentioned here. So Oracle home, DB home, database, or the RAC software, all are like referring to same. So what we do, how we install, how the installation works, a GI, ASM or clusterware installation, we download 19C GI or ASM or clusterware software on node 1, only on node 1. Let's assume you have set up all the IPs, your public IPs, private IPs, scan IPs, VIPs, you have all set up done on these two nodes. Now we are installing, we are proceeding with the installation. We download this 19C GI software on node 1 and we unzip that GI software into U01 app 19C grid. So this is your standard naming convention. If I go to my lab here, ls-l, you can see all this grid software here, or you can do ls, you can see all the grid software here. So we download that grid software and we unzip here on this standard location, U01 app 19C grid. Once we download and unzip, inside that we have this grid setup.sh. We have this grid setup.sh. So we can go and then run that grid setup.sh. That will going to launch the GUI screen. When the GUI screen is launched, we will give that. It will ask you to enter this node physical IPs, your VIPs, and scan IP details for both the nodes. We'll enter that both the node physical IPs, VIPs, and scan details. Once we give that and hit submit or start install, it will copy that ASM or GI software from node 1 to node 2. So we created these directories on both nodes. You have to go ahead and then create these directories in advance on both the node. And we unzipped software only on node 1. But the moment you hit enter that installation process, it will copy that ASM or GI software from node 1 to node 2. It's going to copy over here and it will start this. Once the copy is done, it will set up your two node rack clusters. Node 1 and node 2 will start communicating each other. And then your ASM instance 1 and 2 and ASM storage, everything will be formed. There's a quick comparison here. So you no need to install on both the nodes, the software. You have to be only one node. Right? This is your node 1 and same thing here on node 2. ls. Here. Remove this one. Grid. If you do ls, all this software, whatever you're seeing here, so all those you can see it here. And if I, right, so let's go back here now. And this ls, both the grid on both the nodes, node 1 and node 2, the same software we downloaded only on node 1, we installed it, it copied to second node. and the rack setup is done. And for the Oracle home, we'll go and then the next software installation. The Oracle home, database home, rack home installation. We download that 19C Oracle home database software on node 1, and we'll unzip that 19C software into that directory. This is the standard naming convention as per Oracle. U01 app Oracle product 19C db1 on node 1. If I go here on node 1 ls, we have this db home software here. In that we have this run installer. We'll go ahead and /run installer. We'll run this one right here. Unzip that 19C software, and then you can run this run installer. The moment you run the run installer, already the rack setup is done in this step 1 here, grid installation. It has already configured 2-node rack. And then it wanna ask you to select what all the rack node you want to install this Oracle home. You want to install it on only 2-node rack cluster or 4-node rack cluster. Let's say your rack cluster is a 4-node rack cluster. But do you want to install this Oracle home on all the 4 nodes? Or you want to install it on only node 1 and node 2? Or you want to install it on only node 1, 2, 3? You don't want to install on node 4. You have to select all those rack cluster nodes, checkbox, and then hit submit. The moment you submit, you're gonna set up node on Oracle home, and you're gonna copy that Oracle home to all other rack cluster node what you selected. That concludes your Oracle software installation. Node 1. Right, let's put here. Right. So node 1 grid is done, and node 2 Oracle home is done. And now finally database creation. So database creation is like you're gonna connect to that node 1 and go into your Oracle home bin. Even you can go to node 2 also. That's fine. Anywhere, any of the cluster node you can go. Go to that Oracle home bin and run this DBCA, database configuration assistance. So once you run this one, it's going to ask you all these questions. What is database name, SID, SGA, PGA, data file location, FRA. You can pass all those parameters and hit submit, and your rack database will be configured. Here, final step will be like after final installation will be DevDB instance 1 will be on node 1, and DevDB instance 2 will be on node 2. Right, so quickly here demo on my current lab here. So PWD, this is your Oracle home on node 1. As part of installation, you're going to copy that software into your second node here. And once both the nodes are ready, all your PSF and EF grep SMON. I'll go back to this window here. PSF and EF grep SMON. You have your ASM1 and DevDB instance 1 on node 1. Then the second node, ASM2, DevDB instance 2 on second node. So both the nodes you have configured successfully, the rack and the ASM and database. So I'll take a pause here for any doubts or questions here on how installation works. So this installation can be started only after you configure your all the IPs first properly. For that you can start with your installation. No questions, so good, all fine.
Malik, one question.
Yep.
Regarding the database configuration, instance-wise, the SDA will differ, right? For example, instance 1, I can
At
set.
the time of installation, it will be same for everything. After the installation is done, you can change it whatever you want. Node 1, you can go and then increase your SGA size. Node 2, you can go and then decrease your SGA size. You can manage your instance, customization you can do.
Okay, good.
Right. And now couple of command. Once that is done, so earlier what we should do as a standalone database, we used to manage database instances. So which includes your memory plus a BG process. So earlier, like for the if you're working on a standalone, so you're gonna manage your database instance, which is you're basically managing your memory plus background process. So what I mean here, let's say you have only this standalone lab server where you will be running your only one database. So we'll just maintain that memory and background process and maintain that a database. So the two things what you're going to maintain for the standalone. Right, so let's consider this is for your standalone. Um, for the standalone, you'll just maintain your manage your database instance plus database, that basically your data files. In case of RAC, manage your database instances. Here it will be only DevDB, only one database DevDB and one database instance. So it will be like DevDB database, all the data files associated with that, and DevDB instance. In case of RAC, you're going to manage your database instances. It will be like DevDB instance 1 and DevDB instance 2. On node 1 and node 2, you have two node, you have to maintain that instance. Just now somebody asked, right? The HGA, PGA. You can manage your instances, the memory and background process on node 1 and node 2. And also you can manage your database. Database is nothing but your data files. That's a RAC database and standalone database management. That all looks good. Whatever you used to do on the standalone database management, instance, memory, background process, same thing we do here. We manage the instance, memory, background process, but across multiple instances. Then what else? What extra comes here in case of RAC? Cluster management. So this is one extra what we get here in case of RAC. So a lot of services are daemons in cluster. So in case of standalone, we'll use the same SRVCTL utility. Using SRVCTL utility, we manage your database or database instance. Same thing in the RAC also. We use the same SRVCTL utility to manage and maintain that RAC database or RAC database instance. So one extra activity what is coming in the case of RAC is cluster management. We use a CRSCTL utility to manage our cluster. So this is the major activity. So major activity is your cluster management. That's where you have a lot of challenges here. Here will be lots of cluster resources, lots of cluster daemons. Create lot of cluster resources, cluster daemon, cluster startup sequence. Many more things will come into picture here. And that's where the most of the DBA's challenging part was to maintain and administrate the cluster level management. So I can quickly show few utilities for SRVCTL to manage your database and few commands to manage your clusterware on my lab here. So I'll go with the first database level SRVCTL. Few of the command I'll connect to database. I'll set the environment to my database. DevDB instance 1. I'll run srvctl status database -d devdb srvctl status. So I'm going to check srvctl status, my database instance 1, instance 2, which is running on node 1 and node 2. You can run it from any cluster node. That's the beauty of your RAC or cluster administration. It not necessarily you have to run it from node 1. You can go to node 2, node 3, node 4, whichever node you can run it. So right now I'm in second node and I'll run the same command. srvctl status works fine. So your devdb instance 1, instance 2, which is up and running. So instead of status, you can do config. srvctl config database -d devdb. It's going to show you all the configuration for that database at cluster side. srvctl config, your DB nickname, DB name, your Oracle home, Oracle user, your SP file, password file. Again, domain is not there. Start option is open. Stop option is immediate. Primary role and your disk group. Your database is resides under data and reco, and your groups install and database type is RAC, and your database instances are devdb1, devdb2, which is configured on node 1 and node 2. Right, so those are your sample commands how you can manage or maintain your database. Status. And now if you do stop, you're basically going to do complete database instance down. So your instance 1 and instance 2 both will go down. And at the same time you can do start. So I can quickly run this stop command. So I'm running it from node 1. From the node 1, I'm running this srvctl stop database. So it will gonna shut down your devdb instance 1 on node 2, node 1, and also it will go to the second node. It will stop the devdb instance 2. It's a complete downtime. So again, we never run this command without any approval or without any proper downtime or the change request. So very rare scenario, but yeah, being on one of the cluster node, you can do a complete shutdown activity. Right. At the same
Malik, I
time,
have a question here. If in server 1 we are going to stop the services of the database, right?
right.
Then at that moment on node 2, will the services be up with the second instance, or
That's what I was explaining. It's a complete downtime. You'll want to shut down your instance 1 and also it will shut down your instance 2. It's a complete downtime. You should have a proper downtime approval. devdb1, devdb2, not running, node 1 and node 2. So if you want to do only that a node specific, then you have to go with something else, something like this.
so we have to run this command?
Wait a minute, I'll take those questions. Please stand by. So this is what is your entire DB level. Now I don't want to go for DB level. I want to go for individual instance level. Now I got a downtime only for a devdb instance 1. I want to shut down only devdb instance 1. I don't want to touch my devdb instance 2. Let it be up and running. For that, you need to go for instance wise. srvctl status instance, and you have to give what instance, devdb instance 1, and what database you want, devdb. So I want to go for individual instance wise. Let's say I'll go to node 1. I'll run this one, srvctl status instance and your instance name, and for which database, at devdb. srvctl hyphen instance. What command is that? Help. So help is the other option. If you don't remember the command, you can go with srvctl status and then go for help. That's going to give you a lot of options here. So go for what option you are looking for, SLCTL status, whether you want to look for instance wise, whether you want to look for database. Right now here, what I showed is SLCTL status database. Now I'm looking for SLCTL status instance and your DB name and then your instance name. So SLCTL, just go with this SLCTL status -d or -db. You can go whatever -d, devdb, and then go for node, or if you can go for instance, that's -i and devdb. So this is a brilliant option here. Any command, if you don't remember syntax or status, go for that respective SLCTL status and help, and it's going to easily form your command. SLCTL status instance -db, db name, -instance, and instance name. Now we form the command SLCTL status instance for the devdb -i instance 1. So it says devdb 1 is not running. So I'm going to start only that instance 1. Start instance 1. This is like instance 1 specific. Somebody asked about this question, right? So whatever earlier command is a complete downtime. Everything will be down across all the cluster node. Whatever this command we are doing it is a instance wise. So I'm gonna check my status of instance 1, instance 2. I'm gonna stop my instance 1, instance 2. It's the individual instance, I'm stopping it. I'm gonna start my instance 1, instance 2 individually. Right, so I did the start of my instance 1. So if I run the same command here, status command, it's gonna tell you only that instance 1 is up and running, instance 2 is still down. devdb instance 1 running on node 1, devdb instance 2 which is not running. So you can go ahead and then shut down that devdb instance 1 back again using the stop option. Stop instance devdb1. So you have to remember what activity you are doing, whether you're doing a complete database shutdown, you got approval for complete downtime, go for this SLCTL, stop and start DB wise. If you got downtime only instance specific, you have to use SLCTL status or stop and start instance as a keyword instead of database as a keyword. Right, hope that answers your query, right, Arun? How the instance and database.
Yeah, thank you.
Right. Status, now everything is down. Now you can start both instances rather than starting one by one. You can do SLCTL start database and database name. It will start.
There might be some maintenance activity on a particular server, so we need to run this command, to make the instance down.
Right. That's correct. Somebody asked that question, right? I want to increase SGA on instance 1. So you can do that shutdown on only node 1. Those kind of instance specific.
It may be anything that requires the server shutdown and reboot.
Yeah.
Okay.
The DB name is the same from the both lab, like dev DB. The
Yeah,
DB name should be the same.
Right. You can see this one, right? Your instance 1, your instance 2 will be a node specific, but your database will be remain same. That will be a devdb. Your database is shared in both the RAC nodes as the instance 1, instance 2. Your DB name will be remain same.
Okay. If the DB name is same, then how we just verify that that the DB is running on the primary as behaving like a primary?
Meaning, I did not get your question. What's the primary? Or on what respect or what context you're asking?
Yeah. Actually, how we know this? This is the primary database, and the second one is the standby database.
Standby, we don't have it. This is only the primary database. We don't have a standby for this one. That's your DR concept. Right now, if you run this SLCTL config database, your database name, it will tell you your database is a primary.
Yes.
If you go to your standby, if you run the same command, it says physical standby here.
Okay.
Right? Hope that answers your question. That's the question, or you're looking something else?
Yeah, no, this is the only, but I just it means a little bit confused. Like the database is the same in the both instance, right? Database name is the
Yeah,
same,
that's a
and
rack.
then we
That's a
yeah,
rack
that's it.
concept, right? Your
Yeah.
database is one, but
Mm-hmm.
to connect to the database, you are gonna configure multiple instances on a server. That's a fundamental understanding I just explained here, right? At last yesterday. So your
Okay.
database is one. To connect to the database, you should have one instance. So this is your standalone. But in case of RAC, that the database is one. To connect to the database, you need that instance. So these are your instances which are connected to the same database. That's where the RAC
Yeah.
meaning of.
Okay. Then if we want to down the database in L1, so we just give that instance details.
Instance. That's true.
Okay. Yeah. Okay. Now got it. Okay.
Yeah, like some kind of a maintenance you want to do on this server, like you want to increase CPU, RAM, memory, storage, or any kind of activity you want to do here. Shut down only instance. Don't shut down database. Why you want to
Yeah.
unnecessarily bring down this two?
Yeah. If we run the server CTL command on the database level, then database is stop for the all instance like
Right. That's
L1,
true.
L2, L3.
Right. That's
Oh,
true.
okay. Got it. Okay.
All right.
Means Malik, do we have a signal commands if you want to, make all the instances in the nodes one time go down?
This one, right?
Okay.
The moment you bring down your database, all instance will go down.
And what is CRS-CTL?
That's a cluster word. I had to explain that
Okay.
one.
Okay. Thank
Right. So what we just talked about is the DB level. So whatever we used to manage our database for the standalone, it remains same for your cluster. Even in your standalone, you used to do this one. SSTL config, stop, start. Here only the database because there's only one database and one instance. For the standalone, it's a one command. But in case of rack, you have to be very cautious on whether you're doing maintenance on the DB level or the instance level, which downtime you got it according to your perform. But underlying understanding is remains same. But one extra activity what comes here in case of rack is a cluster management. So this is where majority of the database is just you can say around 30 to 40% of rack course, and remaining 60% of rack course is on about cluster management. So you have a lot of resources here and lot of utilities here. Like few example I can say, I'll set the environment to plus ASM, CRSCTL, stat resource hyphen T and hyphen init. So you have ASM, cluster interconnect, CRF, CRSD. So all of them has its own functionality, and these are your, you know, common entry question. What is CRSD? Cluster Ready Service Daemon. What is CSSD? Cluster Synchronization Service Daemon. What is CSSD monitor? This is CSSD monitor is along with your CSSD. What is CTSSD? Cluster Time Synchronization Service Daemon. What is Diskmon? That's your ASM disk operations. What is ACFS? ASM cluster file system. What is EVMD? Event Management Service Daemon. What is GIPCD? Grid Inter-Process Communication Daemon. What is GPNPD? Grid Plug and Play Daemon. What is MDNSD? It's a message multicast broadcast. What is storage? That's your disk. So you have to know. I just explained about the full form of these keywords, but you have to know why we need this CTSSD, why we need this CSSD, why we need this CRSD. So few examples, CTSSD is for time synchronization, both a cluster node 1 and node 2, make sure that time is always in sync. And CSSD is your cluster synchronization service daemon. Let's say you have this node 1 and node 2. So node 1 will ping node 2 internally, internal communication. Node 2 has to send a response. In case of node 2 is not sending a response, this node 2 will be evicted. That is called your node eviction. So where is the log, what to check? That's again internal. We will cover in our regular classes. This is your cluster resources. You can see here cluster resources on node 1. And all these nodes should be healthy and working functionally fine. Then only your cluster will work fine. Same thing on the second node. Plus ASM2, CRSCTL, stat resource -t, -t-init. So again here also CRSCTL status resource in tabular column, the init process. That's a cluster resources. The node to also have the same set of processes. All should be online and active and should be able to communicate each other. Any one of the service goes down, your cluster service will go down on that node. And again, we'll explain all of these daemons, all of these cluster resource one by one. Since we have this all cluster resource at my cluster side and the OS side also, you can see all the respective daemon. ps-ef grep d.bin. D.bin is your OS level process daemons. Right? What are these? HAS, Ora agent, Ora root agent, EVMD, MDNSD, GPNPD, GIPD, CSSD monitor, OSysMod, CSSD agent, OCSSD, CTSSD, right? CRSD. So whatever this cluster resource we saw at the cluster side, all of them will be running with the OS process. These are your OS process IDs. Any of these process ID kill, your cluster will go down. Right. So to manage, it's a DBA job to manage all of these activities. We DBA has to be very, very careful, and then we should understand what all these daemons and what are the respective job, why we need that process, why that has to be up and running. Same process, same daemons on the node 1 as well. Right, again, we'll explore more in our regular classes. What are these processes, why we need. That's where the challenging part is to maintain and manage your cluster resource, cluster daemon, cluster startup sequence. So I talked about these many resources, which service starts first, which service starts second, and all of them we need to understand. Now, let's say we talked about managing instance. I need to do some configuration. I will shut down my instance 1. And then I'll change that configuration. I'll start the instance. But say your Linux admin wanted to do some OS patching on node 1, or your network admin wanted to do some maintenance on this node 1, the server 1. So it's a DBA job. We need to shut down our instance which is running on node 1, and also we need to shut down all the cluster resource which is running on node 1. So for that we're going to do this CRSCTL check CRSCTL check HAS, CRSCTL stop CRSCTL start CRS. So I'm going to check for individual the CRS process. I'm going to check for this HAS, high availability service. And if I do CRSCTL check CRS, your high availability cluster ready service, event synchronization service, event manager, all are online. And I can check for HAS, Oracle high availability service daemon is also online. So you can do stop CRS. It's going to bring down all the cluster services. When the cluster services are down here, underlining your database, your ASM, everything will go down here. But if I try to do the stop here, CRSCTL stop CRS will not work here if you try to stop it. It says you logged in as a Oracle user don't have the permission to perform the stop operation of your cluster on the node 1. So it says command failed because of insufficient privileges. to do this cluster maintenance, to start and stop, it has to be root user. So most of the environment as a DBA will get a sudo root access permission on the RAC cluster, because there are few commands we run with the root user, there are few commands we run with the Oracle user, there are few commands we run with the grid user. So if you have only limited Oracle access, you cannot do this administrative activities like shutdown of your cluster, start of a cluster. You have to always engage your Linux admin to perform these activities. Because of that factor, most of the environment, most of the customer, when you are working on a RAC environment, you will be having a sudo access to root user. So now I can run the same command stop CRS. So before I stop this CRS, what I can check here, CRS-ETL stat resource -t, and there are a lot of things here. Whatever I covered, listener, database listener, CHAD, network, ONS, proxy, ADVM, your ASM net listener, your data disk group, scan one. Here you have scan one, scan two, scan three, three scan listeners, because we have here scan one, scan two, scan three. We have three scan VIPs configured. Because of that, we got three scan listeners. Again, we'll talk in our regular classes what is this scan listener and all. Now we have this OCR disk group, RICO disk group, you have ASM instance, and you have this ASM net1 network, your CVU, and you have your database. And you have your node 1 VIP, node 2 VIP. Just observe here, node 1 VIP running on node 1 and node 2 VIP running on node 2. If I run the same command, crsetl stat resource -t, you will get the similar output. Plus ASM2. So same thing here, lab 1 VIP, lab 2 VIP running on lab 1, lab 2. That's a node 1 and node 2. What I'm doing here, I'm trying to shut down the node 1. Let's say you have node 1, node 2, where you have ASM1 running here, ASM2 running here, database instance 1 running here, and database instance 2 is running here. So both of them are pointing to your shared database called DevDB. So let's say the client 1, client 2 are connected to your DevDB instance 1, and they're accessing the data. And we have client 3 connected to instance 2. Now what I'm doing, I'm either you shut down your database, or you can shut down your ASM, or you can shut down your entire cluster here. Now I'm doing shutdown of my entire cluster. CRS-ETL stop CRS -f. -f is for force. Without -f is like the smooth shutdown. CRS-ETL stop CRS also works, or you can do forceful shutdown -f. The moment I shut down my RAC cluster 1, what happened to this client 1 and client 2 connected? Remember one of the RAC advantages? Failover. Whatever these clients are connected to DevDB instance 1, they will be automatically failover to your second node. Right? They will be failover to the second node. So how can we see that one? So it's a quick demo. If I shut down here, I'll go to second node, and my database instance here, which is getting shutting down. And after the database instance shutdown, if you see here, Oracle Lab 1, VIP, online, intermediate, and then it is failed over. Failed over meaning it is failed over to your Lab 2. Your VIP will fail over. Whatever running on node 1, now it is failed over. Meaning whatever this client 1 and client 2 who are connected to node 1, the DevDB instance 1, they are automatically failed over to second node, and they continue to run their queries or transactions from the second node. So if you don't have this VIP concept, the moment you shut down your node 1, both the client connection is broken. It's supposed to break, and this client has to reconnect, and the connection will be goes to second node, and they have to re-execute their transaction. So it's for the client point of view, it's for the client it's a seamless. For the client, they don't know There's a failover happens and they are now connected to second instance and they continue to do the transaction. That is achieved with help of these VIPs. If you don't have this VIP, this failover was not possible. That is prior to your 10G. Prior to 10G, we don't have this VIP IP addresses and we don't have this failover feature. All right, go back here now. Your cluster is down.
One
Now
question.
Yeah, go ahead.
The failover will support, as you said, only for the select query, right? For any example update and all, it has to resubmit the users, is it?
Yeah, user will be automatically connected to second instance, but his transaction will fail. He has to re-execute the transaction. But he no need to reconnect it. Already his connection will be passed to second node.
Got it.
Right. And node 1, everything is down. PSF and F grep, D dot bin, no daemon, nothing.
Malik,
Everything
when
is
the
down.
user will shoot the query, will they get the information that the instance was down or the
No.
transaction was cancelled?
Transaction was cancelled. You'll get the transaction failure. You have to resubmit the transaction.
Okay.
Right, and now you can start it. CRS ETL, start CRS again. Right, start CRS is basically it's going to bring that all cluster where including database. So now let's say what happened here. When you start your cluster, it will automatically start your hierarchy. The hierarchy will go like this. Node 1, node 2. So you have your ASM instance 1, ASM instance 2. On top of the ASM, you have your database instance 1, database instance 2. And now before this ASM, we have this CRS. We have this CRS. The hierarchy will go like this. Your CRS, on top of the CRS ASM, on top of the ASM, your database. CRS, on top of that ASM, on top of that your database. If you want to shut down and start up your ASM database instance, no worries. Your ASM and CRS will be still up and running. Only ASM database instance will go down if you run this one. And if you run the same command, CRS srvctl stop ASM, srvctl start ASM, srvctl status ASM. So right now this one, if you connect to node 1 and if you run this command, srvctl stop ASM, the moment you do stop ASM, automatically your database instance will stop here on node 1 and connect to node 2. And after connecting to node 2, you do this srvctl stop ASM, your ASM will go down. The moment ASM go down, your database will go down. Database instance will go down on that node. It's not a cluster wide, it's a node wide. So before you do shutdown or maintenance of any activity on any node, make sure that you got a downtime for that database instance which is running on that. Without that, if you shut down your ASM, it will impact your database instance as well because your database instance is running on top of ASM. Right. And then that's a hierarchy. Database is the top level and then ASM is the middle level. And now the cluster. The cluster is what we just mentioned here. So if you connect to node 1 and the moment you run this CRS stop CRS, it's going to bring down your ASM, it's going to bring down your database because this is a bottom level fundamental hierarchy where you're touching anything on CRS, it will impact your database instance and ASM instance on that node, not on the other node. Other node we're not touching anything. Other node everything will be up and running. If you connect to second node and you do shutdown of CRS and it's gonna impact your ASM, it's gonna impact your database instance on top of that. So understand this hierarchy. Your database will be top layer, and your ASM will be middle layer, and your cluster will be at the bottom layer. So we can do anything on the database instance. Your ASM and cluster will be up and running. If you do any maintenance on the ASM level, it's going to impact your database instance on that node. If you do anything on the cluster, it will impact your ASM as well as it will impact your database instance on that node. So if you're doing a downtime, let's say your network admin is doing a downtime on both the node 1, Oracle Lab 1, and node 2, Oracle Lab 2, he's doing a OS patching parallelly. What you need to do as a DBA, I need to shut down my cluster on node 1, shut down my cluster on node 2, like something like this. CRCTL stop cluster on node 2 and CRCTL stop cluster on node 1. You have to do on both the nodes and then hand it over to your network admin or OS admin who is doing that network level change or OS level change. Once they perform their change activity, then you can come back and then start your cluster on both the node 1 and node 2. Right? So that's your hierarchy at high level I wanted to cover. All right. So hope that is too much. I'm going to wrap it up for today. Again, if you allow me, I can talk more things, but again, jumping on the high level stuff is again too much without understanding a fundamental. Right? Any questions so far?
Yeah, it's Malik sir. I have one question. So, CRCT stop CRS and stop HAs, both are same or different?
The HAS is one of the cluster resource on CRS. So again, that's a different hierarchy. We will explore in our regular classes. So your CRS and HAS will work together. But yeah, so we'll explore more on that HAS and CSST and few more other cluster level daemons or cluster level resource.
It's supported, yeah. If I want to stop the cluster, I can use only for CRS.
Right.
So what is the new features added in 23AI?
23i is only on cloud, no on premises. There are so many features in 23i. Your 23i is called vector database. You can do search or like JSON search, you can do relational search and a lot of features. 23i is like totally new. No comparison. The fundamental architecture remains same, but feature wise is so many features. But again, remember there is no on-premises software yet to release. It's all cloud. All right. So with that, I'm gonna wrap it up for today. Let's see you on our regular classes.
So,
starting
Malik,
from
in most of the environments, do we get the servers in the form of virtual machine or the physical servers?
Both.
Both.
Yeah. So majority of them are your Exadata. So Exadata is your physical box. Most of the customer are in Exadata, so you can get a physical server, physical OS, and physical cell servers, storage servers. All of them are physical. So customer who are not using Exadata, they can either go with a physical server, Linux, or the virtual servers, VMs. All right. Right, so too much now. Let's wrap it up. If no questions, so far so good. Like we covered so many things: networking, installation, and architecture-wise, and the administration of database, cluster,
But you said,
ASM.
but you had said that you will say something about the restore and recovery also.
That's too early. If I start restore and recovery, you have to understand fundamental rule. What is RMAN? How RMAN works? What is RMAN setting? Without knowing that, and it's nothing. You cannot understand much.
But I think RMAN concept is also there in the core DB concept, right? The another batch which is going on.
Yeah, it's a DBI, yeah, core DBI. Yes.
That's true.
Okay. In the RAC, do we have the recovery and RMAN all?
Yes. You attended yesterday session. I gone through that RMAN concept here, right?
Okay, man.
But, okay, just one question. So can he recover only the archive log?
Yes, you can do that.
Oh, I see. Okay.
You can recover your arclog, you can recover your SP file, you can recover your control file, you can recover any data file. So in order to start, again, that's your fundamental rule. What is your database startup sequence? Shutdown to no mount. That's your fundamental. Remember,
Yeah.
as long
No
as you
mount.
have a ground rule on the fundamental architectures are strong, you can able to answer question by your own. But how you can
Yeah.
do that comes into picture only by practice. But to answer that questions, you can answer by your own if you understand the fundamental concept clearly. Shutdown,
Okay.
no mount, mount,
No
and open.
mount. Open.
This is
Yeah.
a typical database startup sequence,
Yes. Yes.
and then you should be able to know what all the files are needed on each file, each page. From shutdown to no mount, you're going to use SP file. From no mount to mount, you're going to read control file. From mount to open, you need all the data files and all the redo log files. So in order to start any database, 1, 2, 3, 4, all these 4 files are must. Your SP file, control file, data file, and read log files. Without these files, you will not be able to start your database. If your data files are missing, your database will never get opened. If your redo logs are missing or oracle logs are missing, your database will never open. And if you don't have a control file, your database will never mount. If you don't have a SP file, your database will never go to no mount. So since these are critical, RMAN will take SP file backup, RMAN will take control file backup, RMAN will take data file backup. Instead of redo log, RMAN will take archive log backup. So these are your supported files in RMAN. SP file, control file, data files, and archive log files. As
Puna
long
sir,
as you are able to take your SP file, control file, data files, and archive log backup in RMAN, once you're able to take these 4 backups, and you should be able to restore all those SP file, control file, data files, and archive log, whatever you backed up. Right? To answer to that question, RMAN is able to restore your archive log? Yes, because we have taken the backup of archive log, and I should be able to restore my archive logs. Whatever you take a backup in RMAN, you should be able to restore it. If you don't take backup, like you have instead of SP file, we have P file. Is RMAN is going to capable of taking a backup of P file? No. Are you able to restore P file? No. And we have a redo logs. Is RMAN is able to take a backup of redo log? No. Are you able to restore the redo log? No. Right? That is your fundamental understanding. If you understand what all backups are supported in RMAN, and then you should be able to answer by your own that what all restores are possible. Right? Remember, redo log backup is not supported in RMAN. A P file backup is not supported in RMAN. And any of the diagnostic files, alert log, trace files, and all, we cannot take a backup of those in RMAN. So restore of that P file, redo log files, alert log files, those are not possible. In thumb rule, what is supported in RMAN? In RMAN, we support SP file backup, control file backup, data file backup, and archive log backup. Only these 4. And then once you are able to back them up, and you should be able to restore all of them. All right.
There is a question in the chat.
All right, yeah, we'll take those questions and we'll wrap it up. Okay, what if we have one laptop with 32 GB RAM and using same laptop? Yeah, you can do that one. DBA course and RAC course. You can start the database machines when you're practicing the DBA course. Once your DBA course is done, you can stop those databases and start your RAC databases and practice over there. Again, you should not run multiple VMs, like 2 VMs for database course and 2 VMs for RAC course. Can I start all the 4 VMs? No point in that. Whatever you are practicing a RAC, you can start only RAC VMs and then you shut it down after that. If you're practicing database, start those database VMs. So 32 GB is more than enough. You can configure your standalone databases, RAC, Golden Gate, whatever. But you need to run only one VM at a time. You cannot run all of them. Like database 2 VM, RAC 2 VMs, 4 VM, I can run it. No. Your laptop itself will crash if you run multiple VMs. Right. And then the other questions, all the nodes should have the same config in the cluster setup. That is advisable to keep consistency across all your cluster nodes. If you are having a 4-node rack cluster, all the 4 nodes should have a same memory, RAM, CPU, storage. If you're having a different configuration, you may end up with messing up the things over a period of time. Always maintain the consistency. What if one laptop with 32 GB and yeah, so I just answered that question. All right. So with that, let's wrap it up for today. We'll continue on 17th with our regular classes. I'm gonna add all those folks into our WhatsApp group, and then I can share all the further details in our group. And please stand by for that. Maybe today or tomorrow I can do that all. All right. With that,
So
let's
what
take
is
a
the
break.
procedure for registering? I just have to send you the fees. That's all, or is there a? Do you
They
have
can
to
ping me
go
in my
to?
WhatsApp. Ping me in my WhatsApp.
Okay.
I'll share the details.
Okay. Okay. Fine.
Thank you, Malik. Thank you.
All right, guys. Let's take a break, guys. Thank you. See you
Sure.
on next class. Bye.
Yeah,
Thank you.
thank you.